Well, I've got a problem. It's come time to replace my battery bank in my home off-grid solar system. Now we've also got a grid-connected solar system as well, and with the recent government rebates on home batteries and the changing in technology, I just don't know which way to go. So in today's video, I'm going to show you my current off-grid solar and battery storage system. I'll show you the on-grid system we've got, and we'll talk through some of the different options that I've got in front of me. So stay with us. This video is brought to you by Regen EV Charging Install, Australia's residential and commercial EVSE installation specialists. Links to these sponsors are in the show notes. Hi everyone, my name's Greg and welcome to the Electric Car Australia YouTube channel. Now if you're new to the channel, please subscribe to the channel. It really helps those crazy algorithms share the love with other viewers. And also if you like this video, please give it the thumbs up. Now, as we mentioned, there's lots and lots going on down here in Australia with the federal government battery rebate for home solar systems, and also the changeover of the technology from lead acid batteries to lithium ion batteries. Now, my regular viewers will know that I was an early adopter with solar, so the off-grid solar system that you can see behind me there on my shed, I built that out over a number of years, and some of the components in that were second-hand. I've done other videos on that, so I'll put a link to those in the show notes. But the key to that system is it's been in for coming up about 16 years now, and it had lead acid battery technology, and the components that are in that system were also geared to lead acid, because back then there was no such thing as lithium batteries. And a side note, I only found out the other day that Sony invented the lithium battery. So back 16 years ago, maybe there was a few in some phones and cameras and stuff, but they certainly weren't in solar storage. So as I mentioned, we'll quickly have a look through all the different components of my current two systems, the off-grid system and the grid-tied system. And we'll also talk about the different options we've got moving forward. Now, this series of videos, or this will be a series of videos probably over the next 12 months, because this is not a decision I'll be making quickly. There's a lot of different options. I'm talking to a lot of different people, and I'm trying to maximize the use of the gear that I've already got, I guess, which will not only help lower the price, but it's better from a sustainability perspective. I don't want to be throwing out everything I've got and just replacing it with all new stuff. So let's go and have a look at the different components. So there are the panels that are involved or part of the off-grid system. So they're running two separate, the name escapes me now, but two separate sort of systems into the solar controllers, and we'll have a look at those shortly. And part of the reason is because the solar controllers are limited, given this is a 24-volt system, with the maximum voltage that we can manage with the solar controllers and also the wattage. So there's two separate lots of panels. The ones at the front there are REC panels that I bought second-hand, and the ones at the back are, I forget the name of the brand, but they're a US-made panel, and I imported them, believe it or not, directly from the US into Australia myself, because this was back when solar panels were really, really expensive. So those ones up the back there, they were thousands of dollars. And there's generally we've got about just over 4 kilowatts there. So each of the grouped panels is about 2.2 kilowatts. So the ones at the back there are 2.2 kilowatts, and then the ones down the front are 2.2 kilowatts. I'll just mention one of the challenges with the panels. Unfortunately, the ones at the back are a bit of a weird configuration. So they're classed as 12-volt panels, whereas the ones at the front are 24-volt. And that will cause me a bit of grief, as I'll explain later when we look at the solar controllers. But before we look at those, let's go and have a look at the lead acid battery bank. So here's the battery shed. Now, as I said, this is old lead acid technology, so you've got all the warning signs, which are now starting to get a little bit faded. Here's the battery bank. Now, this is a DIY system, so it's not necessarily nice and neat like you would normally find in a professional sort of done program. So down the bottom there, we've got distilled water. Now these batteries, you need to top up the distilled water at about every 4 weeks, I guess. And you do that through the caps at the top there. These are homemade sort of insulation things just out of 90mm stormwater pipe. So cut those, put them over, because if you drop a spanner on that, that arcs like a arc welder. So that protects if you drop anything metallic across there. But this is where you pop these up. There's little float controllers in there, or little floats, and that tells you it's full of water. So yeah, that water there, I go through about 5 litres every 6 weeks. So it's quite onerous having to top them up. All that goes away with lithium. And you might be wondering what this inverter's doing here. So this is a secondary inverter. As I mentioned, this is a 24-volt system. So to give me some extra energy capacity, this was a second-hand inverter I bought. Sat on the stand here. I've got a couple of leads plugged into it. One of these runs my pool pump, so the chlorination pump, and another one I can run, we bake bread and that sort of stuff. So what that does, just separates it off the normal inverter, which we'll have a look at shortly. So this is just giving me some extra capacity. You wouldn't normally have a sort of setup like this. So we talked about the water and having to water the batteries, which is a bit of a pain, and maintenance in these old lead acid batteries. So I keep a log for that sort of stuff. But the interesting thing, I guess, when we're talking about lead acid battery capacity compared to lithium ion battery capacity, it's a bit difficult to actually directly compare them, because lead acid batteries generally work on an amp hour of energy discharge. And the slower you discharge a lead acid battery, the more energy you can get out of it, and the easier it is on the battery. So what that means is if you discharge it quickly and hard, so you're working your inverter hard, your batteries aren't going to be able to deliver as much energy over a time frame, and it'll also wear your batteries out. So when you're comparing them, these are quite large cells. So these are 2-volt cells. So that adds up to 24 volt with the number we've got there. And they are 1080 amp hours of energy storage if you discharge them at, and I've got it wrote down here somewhere, C5. So that is a reasonably fast discharge. If you discharge them at C100, that gives you 1500 amp hours of energy. So yeah, it depends on how you discharge them, how much energy you get. So that's a bit of a complication with lead acid. Why I'm going through this is because I'm trying to compare the kilowatt hours of energy that are in these battery banks, as far as my old one, comparing it to a new lithium ion one. So I'm not great at this, and I might have had this incorrect, but I worked out that I've got about 1 kilowatt hour of storage in these giant lead acid batteries. Now, you don't normally just walk into a shop and buy these. These were specially ordered from a commercial battery store, and these are off-grid solar backup type batteries, the type of thing that telecom or telecommunication companies had years ago in those backup systems. So these are very, very big, heavy batteries. But at the C100 rate of 1500 amp hours, I worked out I've got about 1 kilowatt of storage. If I was to discharge them even harder, like quicker, I'd have less storage. So I'm working on that about ballpark, and that's at 30% depth of discharge, or DOD. So again, that directly relates to the lifespan of your battery. The quicker and deeper you discharge your batteries, the more or the earlier you'll kill them. And the same does go for lithium batteries and electric vehicles, but not so much, because lithium is a newer, better technology, and it's better managed for that sort of stuff. So lead acid, as most people will know, you do not want to discharge them too deeply, because you will prematurely kill them. So I have never discharged these batteries below 30%. So based on that, I reckon these big batteries provide me about 1 kilowatt hour of storage overnight, which isn't a lot compared to new lithium. Okay, so that's the current battery technology, which, as you can see, not great for storage, not great for maintenance. You're always looking after them. But having said that, it's a tried and tested technology, been around forever. But it is pretty crazy to think that you've got to leave about 70% of the battery's capacity sitting there all the time doing nothing, and that costs you money. Just on a return on investment basis on these batteries, I'll show you shortly a kilowatt hour meter that I had in there to measure the amount of energy that I pulled out of these battery banks. Unfortunately, I didn't realise, but it looks like it died about 12 months ago. So it's difficult for me to work out exactly, but I would say these haven't quite paid for themselves. But again, bit unknown because the kilowatt hour meter died. However, I will be able to sell these. I'm hoping I can sell them to somebody who needs an off-grid system. They don't need a lot of capacity in it, but these have still got a lot of life in them. So you definitely wouldn't scrap them. They would be worth money for the lead as scrap metal, but they're too good to do that. So I'm hoping I can sell them to somebody. So that'll offset a little bit of the cost. At best, I'd say I've broken even. These are 10 years old now. I did have a smaller battery bank on this system before I put these ones in. So yeah, 10 years, I reckon these have only just paid themselves off. So here we are inside the shed. Now this is where the control gear is. So this system has two separate lots of gear in here. We have the maximum power point trackers, or the charge controllers. Now they're the units that connect directly to the DC solar panels, and we also have a off-grid pure sine wave inverter, and that makes the DC energy coming out of the battery, inverts it into AC energy, which we can use in the house and also to charge the car. So firstly, let's have a look at the AC inverter. So this is it here, Latronics. Unfortunately, this company has just recently closed down. They're at Moffat Beach here in Queensland. These inverters are absolutely bulletproof. They're a pure sine inverter. They have a big brain fart transformer in there. So they weigh a ton. This is a 24 volt, 2300 watt inverter. I think it surges up to about 6000 watts to start appliances and stuff. Now, there's only a couple of things that this inverter won't run. It won't, unfortunately, run a 10 amp EV charger. It won't start my air compressor, which has a quite a large motor on it. And there's a couple of other bits and pieces, but generally it runs our house, majority off-grid. Over here, these are the maximum power point trackers. So these are Outback Power Systems Flex Max 80s. So these can take up to 150 volt DC per unit off the solar panels on the roof at 80 amps. So we've got two of them. As I mentioned, we've got two separate units up on the roof coming into these. When I go to 48 volts with a lithium battery, I'll be able to double the amount of panels that each one of these can have connected to it. But because I'm on 24 volts, it's a lower amount. And these are all your breakers and all that sort of stuff. So this gear here, all set up for lead acid battery banks, doesn't communicate. There's no smart communications. This little Outback Power hub, you'll see the little lights communicating there. Pretty much all that does is sends a signal into the house. We have a control unit in the house there that I can change settings, etc. for the MPPs. But this system, old school, no communication with the battery, no communication between these and these. And that's one of the problems I'm up against now. Can these systems work with the new lithium-ion batteries? Because as we'll know, lithium-ion batteries are very temperamental with heat. They need to be closely managed for overcharging and temperature. Unlike the lead acid, which is one advantage of those, they are a little bit more, I guess, tolerant of that sort of stuff. So while I can set a lot of parameters in these, they're not really set up for lithium. So I've got a lot more research to do to see whether I can use these and this with the lithium battery bank. And we talked a bit about sustainability before. Obviously comes into price as well. These are about $1,200 each new. So there's quite a bit of money sitting there. These here, as I said, the company unfortunately has closed down. The gentleman that owned the company decided to retire. These were probably about $2,500 when they were new. This one I bought new. The one in there I showed you, I bought secondhand, and I've got a surprise for you shortly. I'll show you another one I bought secondhand. But you can see this is quite expensive gear, so I don't really want to replace it if I don't have to. And I would probably not get a lot for it because let's face it, who's looking for lead acid type gear these days? Everyone's going lithium. So let's quickly come over to the EV charging station, I call it. So back here in the shed, this is my Fronius portable 7 or up to 22 kilowatt charger. So this is actually capable of doing 22 kilowatt of charging. We only have single phase here, so I can't do that. This is a great charger. I will be doing more videos on this one soon. We've had it about 2 to 3 years now, so I'll be doing a long-term review on that. That plugs into our, obviously, 32 amp plug here, and this is a 15 amp socket where we can plug in the granny chargers or the portable chargers. So this is sort of the EV charging component of the shed. This does not connect to the off-grid system. It's connected to the home grid connected system. I'll show you that shortly. However, this one is on a changeover switch, which I'll show you. So we can switch this onto the off-grid system. So again, depending on what I decide to do in the future, I would like this to be all on the off-grid system, but it depends on which way we go. So let's go outside and have a quick look at the on-grid system. So this one's only about 3 years old, 3.5 years old, and believe it or not, already paid for itself. And that was a combination of a decent sort of grid feed-in tariff. We were getting about 15 cents when we first signed up. And because we had the off-grid system, most of the energy we used in the house come from the off-grid system, so we were maximising what we were pumping into the grid. And like I said, this is paid for itself in about 3 years. So you won't be able to see very well, but there is some panels up there on the barbecue area. There's also some east-facing panels there, and we've got panels on the front of the house. That provides us with 10.5 kilowatts of solar panel capacity. And in under here, under my lovely covers, by the way, we've done a video on these as well. If you've got solar controllers, inverters, batteries, really worth putting a cover like this over them. So I'll put the video for that one down below. So here's our Fronius Flex, no, this is a Fronius Snap inverter. Sorry, getting confused there. So this is a single phase 8.5 kilowatt inverter, which was the largest one we could get on single phase when we bought it 3 years ago. That was just the technology changeover for Fronius as well. So this is a snap inverter. So this one can't, as it is here, connect to directly to the DC batteries. Now, everyone's probably heard of sigenergy, which seems to be taking the world by storm these days. And it's got a bit of a cult following. I even heard somebody say the other day that it's a bit like the Tesla cult. So sigenergy have just taken the world by storm. I don't know a lot about them, but I am hearing really, really good stories. So if you do have a sigenergy home solar system or battery system and you live in Brisbane, drop me a note in the comments, because I wouldn't mind doing an interview on a catch up with you. But I love Fronius gear. It's bulletproof as well. But if we do go with the new federal government battery rebate, we've sort of got to change this inverter over, because the new Fronius inverters connect up nicely. They have an emergency grid circuit that you can use when the grid's down, but this one, not so much. But I've been really happy with this inverter and this system. Like I said, it's paid for itself now. We're still on a 10-cent feed-in, which is not bad. So we are still trying to maximise as much as we can feed back into the grid, because that gives us a little bit of a return. And there's the mighty MG. So that MG there, electric, is around 5 years old now. So if you'd also like to have a look at my long-term review videos of that one, I'll put those links in the show notes as well. Done a couple of videos on that. Very well-priced little EV. They're really good buying now, second-hand. So if you're into EVs, or you want to just dip your toe in for a run-around car, perfect. Check out my videos. Okay, so let's head up to the shed again. A couple of more things I wanted to show you guys here. So just here, this is the subboard in the shed. So what this does, this has the grid-tied electricity coming into it, as well as the off-grid. This is a changeover switch, so we can have grid, or we can have off-grid solar. So the shed works on that, or yeah, we can decide which we want. There's the watt hour meter in there, which died, so that's disappointing. I have to replace that. And just quickly show you where the mains from the off-grid goes over to the house. So yeah, there's a circuit. We've got a couple of circuits in the house. So the overhead cable there above my head, that comes from the shed. So that's like a off-grid solar feed from the shed over to the house. It comes over to this subboard here. Now we've got two power circuits in the house which are totally off-grid. So we plug all of our standing lights into it, microwave, all that sort of stuff. This is a light circuit that once I get a lithium battery bank on the off-grid system, if I do that, I'm going to connect every light in the house to this light circuit as well. So that's how we currently maximise our off-grid consumption over in the house and also in the shed. Now here's the little surprise I was going to show you. So over the years, I've always kept my eye out for good second-hand stuff. Now this here is a 5,000 watt or a 5 kilowatt second-hand latronics inverter. So same as the one I showed you over there that I've currently got, but it's a 24 volt one. This is a 48 volt one. Look at the really good quality, thick battery lugs on them. This inverter has hardly been used, and I got this for a really good price. I've had it sitting in the cupboard here for a couple of years because I did know at some point that I would be upgrading my battery bank, and I wanted to go from 24 volt to 48 volt. So I bought this little baby cheap when I spotted it. Really nice guy bought it off. He was selling the property and the new owners didn't want off-grid solar. So he decided to pull the components out. So I'm hoping again that I can get the old technology stuff like this working with the lithium stuff. Well, that's it for this video. And just to wrap up, to let you know, we pull about 8 to 10 kilowatt hours of energy out of our off-grid system every day, and that obviously reduces the amount of solar we use from the grid system, so therefore we can pump most of it into the grid, and it also reduces the amount of power if we have a cloudy overcast day that we need to pull from our other system because we can balance it across the top. What we generally do with the EV charging, if we don't need to charge quickly, we'll set the Fronius charger to only 6 amps. And what that does through the day on the grid connected system, that just skims off the top, because here in Queensland, we've got a 5 kilowatt hour limit to input into the grid. So it just skims that extra 1.5 kilowatts off the top. So we're still maximising what we're sending to the grid. We're trickle charging a bit into the car. And again, we're maximising that grid feed-in. But as we know, feed-in tariffs are dropping. We are expecting ours to drop in the near future. So again, we're trying to decide whether we're going to go lithium-ion battery and beef up this off-grid system, or whether we're actually going to go on-grid lithium battery system. And the advantages of that is that we can potentially share the energy from here across to there. We can do some energy trading. You've probably heard of things like Amber Energy, where you can sign up for wholesale rates. So that's really what we're deciding about now. Do we take advantage of the federal government rebate on batteries, which pays for about 1/3 of the cost of your home battery? To do that, we'll need to change our existing system over there. We'll need to also update the inverter, and we can increase our solar panels from 10 to about 15 kilowatts maximum on a single phase system in Queensland, and we can increase our inverter to I think it's 10 kilowatts where we've currently got 8. So we can beef it up a little bit, but it is going to be a bit costly even with the rebate. This system, my biggest cost if I can use all this gear, will be the lithium battery bank. The one we're looking at the moment, it's probably around $4,000 to $5,000 to give us, I think it's 22 kilos. 22 kilos, it's late in the day. 22 kilowatt hours of storage. So we're going from lead acid with about 1 kilowatt to 22 kilowatts. And we can cycle those lithium batteries down to about 80% depth of discharge. As I mentioned with the lead acid, we can only go about 30%. So not only are we getting a ton more storage, but we can actually use more of the storage in the battery rather than leave it sitting there. So look, I hope you enjoyed that video. As I mentioned, there'll be lots and lots more coming with different considerations, etc., as we make this decision. Probably going to be 12 to 18 months before we fully go through it. We might have some interviews with some other grid installers, etc. So we'll just see how things go, but really hope you stay with us for the journey. As I mentioned, if you haven't, please subscribe to the channel, give us the thumbs up, and if you'd like to flick us a couple of dollars, really appreciate that as well. There goes the cooling fan on one of the MPPs. Sun's nice and bright this afternoon, so it's kicked in to cool it down. But if you have been, thanks very much for watching. Take care, stay safe, look after your friends and family, and we'll talk soon. Cheers.